Welcome to today's video. Have you ever wondered where the baking soda in your kitchen comes from? This everyday powder, known scientifically as sodium bicarbonate, is far more than just a simple ingredient in baking. It's also used in cleaning, agriculture, fire extinguishers, and even large-scale industrial processes. Today, we'll explore the fascinating journey of baking soda, from its origins deep in the earth to the many ways it ends up being used in our daily lives. So let's dive in. At its core, baking soda is a compound called sodium bicarbonate. It can be made in laboratories, but much of what we use is actually mined from natural deposits that were formed millions of years ago. These deposits are the remnants of ancient lakes that dried up, leaving behind mineral beds, including sodium bicarbonate. One of the largest deposits of this substance can be found in northwestern Colorado, USA. The geological history of the region created vast, mineral-rich layers beneath the ground that we now mine for baking soda. Mining baking soda is an impressive feat of engineering and science. The process starts deep underground, where sodium bicarbonate deposits are located. Instead of traditional mining with heavy machinery, companies use a more efficient method. Hot brine, basically water mixed with minerals, is pumped into the earth. This hot solution dissolves the sodium bicarbonate, turning it into a liquid mixture that can be extracted from the ground. One cool thing about this process is that the brine isn't just fresh water. It's actually recycled from earlier mining operations, making the entire process more sustainable. Once the sodium bicarbonate-rich solution is ready, it's pumped to the surface and sent to a nearby processing facility. Once the brine reaches the facility, the refining process begins. Large tanks hold the brine, and technicians monitor it to ensure the concentration of sodium bicarbonate is just right. The next step involves cooling the liquid. As it cools, the sodium bicarbonate starts to crystallize. This is when those fine white crystals we recognize as baking soda start to form. The brine passes through a series of tanks, each one gradually lowering the temperature. The sodium bicarbonate crystals grow larger and heavier, eventually sinking to the bottom. By the time the liquid reaches the final tank, it's become a thick, crystal-filled slurry. At this stage, the slurry is pumped into a machine called a hydrocyclone. This device spins the mixture at high speeds, separating the sodium bicarbonate crystals from the remaining liquid. The water, or brine, is expelled, while the heavier sodium bicarbonate crystals are collected. The end result is a thick, white substance that looks a bit like meringue. However, there's still more work to do. This slurry only contains around 40% sodium bicarbonate, so it needs further processing. Next, the slurry is sent into a centrifuge, where it's spun at high speeds to remove even more water. What remains is a substance called wet cake, sodium bicarbonate, that is about 95% pure. To get the product to its final form, the wet cake goes through one last step: drying. The wet cake is mixed with dry sodium bicarbonate powder, which helps to absorb the remaining moisture. Then it's sent through a dryer that removes the last bit of water, turning the sodium bicarbonate into the familiar powder that's ready to use. But before it can be packaged, the baking soda is sorted into different grades. These grades are based on the size of the crystals. The powder passes through a series of vibrating screens that separate the crystals by size, ensuring that the baking soda meets the specific requirements for different uses, whether for baking, cleaning, or industrial purposes. Ensuring that the baking soda is pure and meets high-quality standards is crucial. Technicians take small samples of the baking soda, dissolve it in water, and add acid to neutralize it. This allows them to measure the purity of the product. They also use special screening devices to make sure the granules are the right size. Once the baking soda passes these tests, it's ready for packaging. In many production facilities, robotic arms handle the packaging process, filling bags and ensuring precise measurements. For commercial clients, such as bakeries, these bags can contain up to 55 pounds of baking soda. Now, let's talk about where baking soda goes after it's packaged. Of course, we know it's a popular ingredient in baking, helping cakes, cookies, and other baked goods rise. But its uses don't stop there. In agriculture, Baking soda is used as a feed additive for livestock. It helps regulate the pH levels in animal feed, which aids in healthy digestion. Its ability to neutralize odors and its mild abrasive properties make it a popular ingredient in cleaning products too. You might even have seen it used to scrub countertops or clean teeth. Interestingly, baking soda is also a key component in fire extinguishers. When exposed to high heat, it releases carbon dioxide, which helps smother flames. And there you have it, the fascinating journey of baking soda, from deep underground deposits to your kitchen cabinet and beyond. Whether it's lightening up your favorite cake recipe, feeding livestock, or helping put out a fire, baking soda plays a surprising and essential role in so many parts of our lives. It's an incredible example of how natural resources, advanced science, and innovative engineering come together to create a product that's both simple and versatile. Thanks for watching. If you enjoyed this video, make sure to like, comment, and subscribe for more content on the everyday wonders that make our world go round. See you next time.